It's 2:47 a.m. Half the world is asleep. The oceans are moving the way they always do. Animals are out in the dark, doing what they've done for millions of years. Everything feels normal. But somewhere, in an observatory in Chile, a scientist is staring at his screen. His coffee is going cold. He hasn't blinked in 30 seconds. Because the data doesn't make sense. He checks the calibration, checks it again, calls his colleague. She looks at the screen, goes quiet. They both look out the observatory window, at the sky, at the exact spot where it's supposed to be. And it's not there. No explosion, no warning, no sound. Just a black emptiness where the moon used to be. Within 6 minutes, observatories across the world confirm the same thing. The calls start flooding in. Governments are woken up. The feeds go insane. The moon is gone. And here's the terrifying part. That's not even the disaster. That's just the beginning. Because what comes next happens slowly, quietly. And by the time most people realize what's unfolding, it's already too late to stop it. Here's something most people don't think about. We assume gravity works instantly, like flipping a switch. But Einstein's general theory of relativity tells us something different. Gravity, like light, travels at the speed of light. The moon is about 384,000 kilometers away from us. That means moonlight takes about 1.3 seconds to reach Earth. And gravitational information? Same thing. It also travels at the speed of light. So the moment the moon disappears, Earth doesn't feel it immediately. There's a 1.3 second delay. And then, Earth suddenly finds itself in a universe without the moon's gravity pulling on it. In that instant, a 4.5 billion year gravitational partnership is severed. Think about the mass we're talking about. The moon has a mass of roughly 7.3510 squared kilograms. That's an almost incomprehensible amount of matter. When that mass disappears, the curvature of space and time in our neighborhood changes too. And here's something most people don't realize. Technically, the moon and Earth don't orbit each other. They both orbit a shared center of mass called the barycenter. With the moon gone, Earth's orbital dynamics shift subtly but immediately. The first thing you'd physically notice on Earth's surface would happen in the oceans. Right now, the moon's gravity constantly pulls on Earth's oceans, creating two large tidal bulges, one on the side of Earth facing the moon and one on the opposite side due to inertia. As Earth rotates, we experience these as high tide and low tide. The moment the moon disappears, those tidal forces collapse. The sun still creates tides, but solar tides are only about 1/3 as strong as lunar tides. So overall, Earth's tides would weaken by roughly 70–80%. But this isn't a simple sea level drop situation. The oceans would now be searching for a new equilibrium, and all that water that's been rhythmically moving for billions of years doesn't just stop. Coastal resonance effects would create chaotic currents. Unusual standing waves would appear in certain regions. Scientists would be watching satellite data with their jaws on the floor. And the damage to ecosystems would start almost immediately. Tidal wetlands, estuaries, and coastal ecosystems would be the first victims. Crabs, mollusks, shellfish, and countless intertidal organisms have evolved around the lunar cycle. Their biological clocks are tuned to it. Without it, that rhythm is gone. Here's where it gets really serious. The oceans aren't just bodies of water, they're Earth's climate engine, and the moon plays a role in keeping that engine running. Lunar tides help mix the deep ocean. Warm surface water and cold deep water get stirred together. This circulation is what distributes nutrients through the ocean. Tiny microscopic organisms called phytoplankton depend on those nutrients to survive. And here's the thing. Phytoplankton produce roughly 50% of Earth's oxygen. Half the air we breathe comes from these tiny ocean creatures. Without the moon, ocean stratification would increase, meaning the warm and cold layers would separate more and mix less. Nutrient circulation would slow down. Over the long term, the marine food chain would destabilize. Coral reefs could collapse, fisheries would shrink, and the ocean's ability to absorb carbon from the atmosphere, which plays a massive role in regulating our climate, would be fundamentally altered. In climate science terms, this is catastrophic. Think of Earth as a giant spinning gyroscope. At the equator, Earth's surface is moving at around 1,670 kilometers per hour. But that speed has been slowing down, and the moon is the reason why. This process is called tidal braking. As Earth rotates, the tidal bulges don't perfectly align with the moon. They're slightly ahead because Earth rotates faster than the moon orbits. This misalignment creates a gravitational tug that slows Earth's rotation and pushes the moon a little further away every year, about 3.8 centimeters per year. Billions of years ago, a day on Earth was only about 6 hours long. The moon has been gradually lengthening our day ever since. If the moon disappeared, that braking mechanism would stop. Earth wouldn't suddenly start spinning faster, but the long-term evolution of its rotation would change completely. Atmospheric circulation patterns, the Coriolis force, jet streams, all of these would slowly adjust to find a new balance. This is arguably the scariest part. Earth's axis is currently tilted at about 23.5 degrees. That tilt is what gives us our seasons. But here's what most people don't know. That tilt is stable largely because of the moon. The moon's gravitational torque acts like a stabilizer on Earth's axial wobble, similar to how a gyroscope stays upright. Without it, Earth's axial tilt could wander chaotically over millions of years. We actually have a real example of this in our solar system, Mars. Mars has no large moon to stabilize it. Its axial tilt has varied wildly over millions of years, anywhere from 10 degrees to 60 degrees. The result? Mars has had a chaotic, unpredictable climate history. Without the moon, Earth could experience the same thing. Imagine Earth's tilt shifting from 23.5 degrees to 45 degrees. The polar regions would get near constant sunlight in summer and total darkness in winter. Equatorial regions would experience violent seasonal storms. Monsoon systems would collapse. Agriculture would become unpredictable. Antarctica could melt and grow tropical forests, while equatorial regions could experience ice ages. Entire civilizations would have to relocate. The moon isn't just a physical force on Earth. It's a biological clock for countless species. Studies show that many animals don't just follow circadian rhythms, the 24-hour day/night cycle. They follow circulunar rhythms tuned to the lunar cycle. Coral spawning is synchronized to full moon timing. Sea turtle hatchlings use the moon's reflection on the ocean surface to find their way to the water. Owls and nocturnal predators adjust their hunting behavior based on moon phases. Countless migratory species use moonlight for navigation. When the moon disappears, Earth's biosphere doesn't just lose a light source. It loses an evolutionary timing system that life on this planet has been calibrated to for hundreds of millions of years. Even the solid Earth would be affected. Lunar tidal forces don't just move water. They also cause tiny deformations in Earth's crust, shifting it by about 20 to 30 centimeters. These periodic stress patterns affect fault systems across the planet. Some scientists have speculated that lunar tidal forces may play a minor role in triggering earthquakes and volcanic activity. Without the moon, the pattern of stress on Earth's fault lines would gradually redistribute in ways we don't fully understand. The moon can't just disappear. It would violate the conservation of mass and energy, one of the most fundamental laws of physics. So where did its mass go? Into another dimension? A black hole interaction? Some unknown quantum phenomenon? humanity would suddenly realize something profound and humbling. Even with all of modern science, we don't fully understand every rule the universe operates by. In the long run, Earth might still be technically habitable, but it would be a fundamentally different planet. Seasons would become unpredictable, the climate would be unstable, oceans would be biologically weaker. Ecosystems would be radically altered. Human civilization would have to adapt on a scale never seen before. Artificial environments for agriculture, completely redesigned coastal cities, and a psychological shift in how we relate to the world around us. Because the moon isn't just a physical object. It has been intertwined with Earth's evolution, biology, culture, and civilization for billions of years. Our calendars, agricultural cycles across every culture, are all built around it. Ancient humans hunted, traveled, and held ceremonies by its light. Some planetary scientists argue that without the moon's stabilizing role, complex life on Earth may never have developed in the first place. The billions of years of relatively stable climate that allowed advanced ecosystems to evolve. That stability was, in part, the moon's doing. Every night, the moon rises silently and does its job. It sculpts our oceans. It steadies our axis. It moderates our climate. It keeps the rhythm of life ticking for millions of species. And it has been doing all of this for 4.5 billion years without us ever thanking it. The moon isn't just a rock in the sky. It's our planet's silent stabilizer, its ocean sculptor, its climate moderator, and in a very real sense, it's the reason complex life, including us, exists on this pale blue dot. Next time you look up at the night sky and see it glowing up there, maybe take a second to appreciate it, because without it, none of this would exist. What do you think would happen first if the moon disappeared? Drop your thoughts in the comments.